Unit 9, Lesson 4, this is video number 1, and we're going to start by doing something you've already done in Lessons 2 and 3, and that's how can we evaluate trig functions. So first, if you're not given specific directions, can we use a calculator? Absolutely, as long as it doesn't say give an exact answer. And so I'm going to demonstrate that right now. Notice that we are provided with radians, so I'm going to go up to mode, making sure I'm in radians, and then I'm going to do sine of pi divided by 3, and I'm going to round to the nearest thousands as we spoke about in lesson number 3. So this is approximately 0.866. That's not exact because I'm rounding. The cosine of pi divided by 3 is 0.5. That is exact. It's a terminating decimal. And now we have the tangent of pi divided by 3, and we can see we have approximation again of 1.732. All right, well, in the next 3 examples, we don't have radians, we have degrees. So I'm going to come up to mode and switch it from radians to mode. Excuse me, I'm going to switch it from radians to degrees in the mode section. And now do the exact same thing. We have 60 degrees is 0.866. We have the cosine of 60 is 0.5. And we have the tangent of 60 coming in at 1.732. Now, some of you may have already guessed that was going to happen because on our unit circle, 60 degrees is going to be right here along with 2 pi over 6, also known as pi over 3. So we received the exact same answers, but remember, these are not exact answers. Only the second one is because it's a terminating decimal. So in this lesson, we're going to talk about how to achieve exact answers without using our unit circle, but using the 30, 60, 90 triangle, the ratios of the 30, 60, 90 triangle, and the ratios of the 45, 45 degree 90. Let's start with discussing a few acronyms and ways to remember things specific to their primary trig functions. So sine, cosine, and tangent are the 3 primary trig functions. The secondary or the reciprocals of them would be your cosecant, secant, and cotangent. But we're going to focus right now, again, on sine, cosine, and tangent. How can you remember what they mean in terms of a right triangle? Well, one way is using this analogy. Oscar had a heap of apples. Now, if you can remember that sine, cosine, tangent in this order that you want to write them down, this may be helpful for you. Others may prefer SOHCAHTOA, and it probably relates back to how your geometry teacher taught you. So when we evaluate sine, cosine, and tangent, and all we're doing with trigonometry is we're taking, and specific right triangle trigonometry that we're talking about, is we're taking 2 of the 3 sides of a triangle and we're comparing them based on the directions we're given. So the directions for sine say opposite over hypotenuse. So I want to take the opposite side of whatever this angle is over the hypotenuse. Another way is to remember this is Oscar had a heap of apples. Opposite over hypotenuse. Now cosine is adjacent over hypotenuse, adjacent over hypotenuse. And lastly, tangent is opposite over adjacent, opposite over adjacent. So SOHCAHTOA is SOHCAH and TOA. Different ways to remember what you're being asked to compare. Again, so sine, if I said sine of angle A, well, let's talk about the different sides here. The longest side is always known as the hypotenuse of a right triangle. Now, there's 2 other remaining sides, and depending on what angle that we're evaluating, when I'm asked to evaluate the sine of A, sine is opposite over hypotenuse. Opposite is always going to be directly across. Now, what's this other side? This other side always helps create. So every angle is created here by every angle in a right triangle is created by 2 sides. One of the 2 sides, assuming it's not the right angle, will be the hypotenuse, and then the other side that helps create that angle will be the adjacent side. And a lot of times the adjacent side is what initially confuses students. So in this particular problem, if I just said some random numbers here, this is 3, length 4, and length 5, and I said, what is the sine of angle A? Okay, so I need opposite side over hypotenuse. Opposite side is 3, hypotenuse is 5. If I said, what is the cosine of A? I need adjacent side over hypotenuse. Adjacent to A means one of the two sides help create the angle. Adjacent to A would be 4, and hypotenuse would be 5. And lastly, tangent of A, opposite over adjacent. Opposite is 3, and adjacent is 4. Those are the three primary trig functions. Now, the secondary trig functions relate to each of these. We have the cosecant of A, the secant of A, and the cotangent of A. And they are the reciprocals of sine, cosine, and tangent in that exact order. So the cosecant would be 5/3 because instead of opposite over hypotenuse, it's hypotenuse over opposite. The secant of A would be 5/4 because instead of adjacent over hypotenuse, it's reciprocal. It's hypotenuse over adjacent. And then lastly, instead of 3/4, it would be 4/3. An important thing you may hear is all-star trig class. So all-star trig class makes this C shape as we go from quadrant 1, quadrant 2, quadrant 3, and quadrant 4, always in that order, quadrant 1, 2, 3, and 4, and it helps us to determine what is positive. Remember, we're used to x, y as our ordered pairs, but in trigonometry, we have the cosine followed by the sine. But it works the same way as x and y. So in this position, think of this, our x's would be positive, and so would be our y's. And so both the cosines and the sines are positive. Now, how do we achieve tangent? Tangent, remember, is going to be opposite over adjacent, also known as the sine divided by the cosine. So if I had two positive numbers, and I divide two positive numbers, I'm also going to end up with a positive. That's why tangent is also positive in quadrant 1. Now in quadrant 2, we have x's or cosines that are negative and y's or sines that are positive. So I'm going to have values in here like -2, 3. -2 to the left or 2 to the left, the negative sign means go to the left, and then +3 means go up. That's an example of an ordered pair you would find in the second quadrant. So in the second quadrant, the x's, the cosines, are negative, but the sines are positive. So the sines are positive in quadrant 2. What will the tangents be? Well, the tangent is sine divided by cosine. If we know that the cosines or the x's are always negative, this is a negative, and the sines are always positive because they're above the x-axis, a positive divided by negative is always a negative. This tells me where are things positive. So all things sine, cosine, and tangent are positive in quadrant 1. Only the sines are positive in quadrant 2. Only the tangents are positive in quadrant 3. And only the cosines are positive in quadrant 4. So what is negative here? Cosine tangent. What is negative here? Sine cosine. And what is negative here? Sine tangent. Let's get started. So what are we going to do right now? We're not going to rely on the unit circle to tell us the answer. We're going to only be able to use it. The same will be true when you take some practice quizzing on your exam. There will be a portion of their exam when you will have to rely on this information. It will have to be memorized. So our first step is we want to identify where 150 degrees is. So I know that's 30, 60, 90, 120, 150. Here lies 150 degrees. The next is I wanted to be able to evaluate the 6 trig functions without the use of the calculator. I want exact answers, and that's the main part of this lesson. So how do we go about doing this? So what I'm going to do is I'm always going to create a triangle, and it always goes back to the x-axis every time. So I go straight down, perpendicular, creating that right triangle, and I'm going to come off to the side and do that right now. Now I got to think of these measurements. So if this is 150, and I know that a straight line is 180, that means there's 30 degrees remaining here. So this is 30, and that remains 60 in order to have 180 degrees, the sum of the angles in a right triangle. So I'm going to come back up here, and opposite of 60 degrees is going to be the ratio of radical 3. Opposite of 30 is 1, and these should be things that you may not have memorized, but you've learned in geometry. Let's get started. So we're going to do the sine, and this is the angle that I want. It's that interior angle that I'm always going to be evaluating. For us, that interior angle is going to be right here at 30 degrees. Also, what we need to keep in mind is the all-star trig class. So I'm going to do all-star trig class. And this tells us what is positive. So I'm going to evaluate the sine of 150 for an exact measurement, the cosine of 150, the tangent of 150, and then I'm going to come and do the reciprocals, which would be the cosecant of 150, the secant of 150, and the cotangent of 150. I need to get the value right along with the sine. Let's get started. Okay, here we go. I know that sine is opposite over hypotenuse. So from this interior angle, opposite is 1. Okay, opposite is 1. I'm going to write this down over to the side here. Opposite is 1, and hypotenuse is 2. Okay, 1/2, I like it. So 1/2, that's great. Opposite over hypotenuse. Now, I'm asked for the sine. I can see that in this quadrant, quadrant number 2, the signs are positive. So I feel really good about this answer. Now let's evaluate the cosine at the same angle. So cosine is going to be adjacent. So what helps create this angle that is not the hypotenuse? That would be radical 3. And then what is a hypotenuse? So this is adjacent over the hypotenuse. Now in quadrant 2, where 150 degree lies, only the sine is positive. That means that cosine is negative. I feel very good about those first 2 answers. Let's do the tangent of 150. Okay, so what I need to do is I need to take tangent is sine divided by cosine, or an easier way when we have the triangle created, it's going to be opposite over adjacent. Now, this is the problem when I'm coming down below to do this. Opposite over adjacent. Mathematically, that's not wrong, but it's an improper form because we don't want to leave a final answer at this level of mathematics with a radical on the bottom. And what I'm telling you directly is if you give me an answer of 1 over radical 3, I can see that you're able to create the ratio correctly for the interior angle of 130 degrees, which equates to 150, but you don't know how to simplify it properly. So how do we simplify this? We are going to multiply the bottom and the top by radical 3. 1 times radical 3 is radical 3. Radical 3 times radical 3 is radical 9. And I end up with radical 3 over, well, the square root of 9 is simply 3. Now this is in proper form. So I want to show you that. If I type in square root of 3 divided by, I got to get outside of that, divided by 3, or if I do 1 divided by the square root of 3, notice how they're the exact same numerical values, but the top one is in proper form. Okay, in quadrant 2, the tangent is not positive, only the sine. Now, how can we use these 3 answers to make life really easy? So I'm just going to take the reciprocal. The signs will remain with it. So cosecant is the reciprocal of sine. It'll have the exact same sign. It'll be positive, but instead of being 1 over 2, it'll be 2 over 1. I feel good about that. Okay, now I'm going to come down to the bottom. I know it's going to be negative. But I need to take the reciprocal of this, which is 2 over radical 3. And the negative sign I've already put in that place. 2 over radical 3 mathematically is correct, but I need to rationalize the denominator. So times radical 3 times radical 3, I end up with 2 radical 3. On the bottom, I have radical 9, which is just simply 3. I do the exact same thing for this third one, but hey, there's a shortcut. Remember, this is equivalent to this, right? They're equivalent. So if I take the first try that I did, which was opposite over adjacent, and I flip it, I end up with radical 3 over 1, making sure that the signs stay the same. So the tangent and its reciprocal, the tangent and its reciprocal have to have the exact same sign. All right, let's go ahead and let's now look, where would I find negative 495? Well, the negative sign says instead of going around, starting here, which I call the start line, instead of going up, we just reverse directions and go down. So I'm going to take 495 and I'm going to subtract 360, which is 1 revolution. Okay, so I need to start here and I need to reverse directions. That's what this means. I need to do 1 revolution. Okay, 1 revolution, that's a 360. And now I need to do an additional 135. So where do I find 135? And 135 is right here. This is where 135 lands. So if I take 135 plus 360, you can see I end up with 495. Also, if you're confused how I got there, this is 3 groups of 45. 45 plus 45 plus 45 is going to be that 135. So here's 45, 45, and 45. Now, how do I make this triangle? This triangle is always going to go back to the x-axis, and it's always going to make that perfect perpendicular 90-degree angle. So I'm going to come off to the side, and I'm going to draw the triangle. Now, I just said this is a 45. So if this is 45, this must be 45 in order to create that right triangle. So we have 45. I can see this is not drawn to scale, and that's 45. And remember, we drew these in our notes a little earlier. This is important that you have down. So across from each 45 is going to be a 1, and across from the 90 degrees is going to be a radical 2. Now we're going to go about doing the same thing we did for our previous example of 150 degrees. So all star trig class. Let's get started. So I'm going to start with the sine. Now what angle am I evaluating? It's always that interior angle. So right here is what I'm evaluating. So sine of, and this is negative 495. Okay, that should just be a degree symbol, sorry. So here we go. The sine is going to be opposite over hypotenuse. So it would be 1 over radical 2, but as you know, we can't have a final answer that has a radical 2 in the bottom. So I'm going to multiply by radical 2 to get radical 2 over radical 4. And simplify, I have radical 2 square root of 4 is simply 2. Now in this quadrant, only the tangents are positive. That makes this a negative 2. I feel good about that. The cosine of a negative 495. Okay, so cosine is going to be adjacent. Remember, adjacent is it helps to create that angle, but it can't be the hypotenuse. So 1 over the hypotenuse. The exact same thing. It's going to be 1 over radical 2, and it simplifies to radical 2 over 2. In quadrant 3, again, only the tangent is going to be positive. Now, the tangent of negative 495. Tangent is opposite over adjacent. So 1 over 1 is 1. And we know in quadrant 3, tangents are positive. Now let's look at the reciprocals. Cosecant of this value and secant of this value and cotangent of the same value. All right, so I know if this was the original ratio that I created, again for sine, so this is opposite and this is hypotenuse. If I take the reciprocal of that, instead of it being 1 over radical 2, it would be radical 2 over 1. And we'd have the exact same thing for secant. But remember, the sine has to carry with it. The sine has to be carried with it. So I'm feeling really good about these answers. Now let's look at tangent. If I have an answer of 1, and now I need to take the reciprocal of it, that means I just put it over 1. Well, 1 over 1 is still 1. If that confuses you, think of this. Tangent is opposite over adjacent. So when I take the reciprocal from this angle and we do adjacent first over opposite as I compare these two lengths of a right triangle, adjacent is 1, opposite is 1. 1 over 1 is still 1. If this primary trig function was positive, then its reciprocal is also positive. There's a new terminology I should have introduced, and it's called reference angle. So when I'm looking at this, I'm looking at it at a reference angle of 30 degrees. That reference angle is always what's the distance back to the x-axis, whether you're going down or going up. So here's a reference angle of 30 degrees. Here's a reference angle of 45. Let me make up another one. If I said 330, the reference angle would be 30 degrees to get back. Or if I said 150, the reference angle would be 30. If I said 260 degrees, the reference angle is the distance back to the x-axis, whether you're going down or coming back up. We're going to do the same thing, but instead of me providing with degrees, which most students prefer as they enter into trigonometry, I'm going to provide you with radians. All right, so we have an angle of negative pi over 3. I'm going to start doing all-star trig class just so I can remember where the different trig functions are positive. And now I need to identify where is pi over 3. I don't want you to get in the habit of trying to convert it into degrees algebraically and then finding it. So I'm going to start by just turning this into a 6. So times 2 times 2, I have negative 2 pi over 6. Maybe that helps. Remember that when we're counting by 6s, and I'm going to go backwards here, it's 1, 2. Remember if there's 12 6s here. So reminder, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I'm going to go backwards 2, 1, 2. So this is where I am, and I'm dropping straight down. So I can already see the distance back to the x-axis is 60 degrees. My reference angle is 60 degrees, which is equivalent to pi over 3. That's my reference angle. I'm going to draw that triangle, and it's that interior angle that I'm going to evaluate. So 60 degrees, 30 degrees. And then I honestly never taught geometry, and so every year when I get to this point, I have to rememorize these. So opposite of 60 degrees is going to be radical 3. So opposite of 60 is radical 3, opposite of 30 is 1, and our hypotenuse is radical 30. Oh, I think I wrote this down wrong. Opposite of 60 is radical 3. This should have been 2. My hypotenuse would be 2. Let's get started. So let's do the sine of negative radical 3, negative pi over 3. Okay, so this is the angle right here that it's that interior angle that I'm always using as I evaluate. And as a reminder, when we evaluate trig functions to receive exact answers, we're just taking 2 of the 3 sides and we're creating a ratio that allows us to analyze it. So what are the directions? SOHCAHTOA. Sine is opposite, so opposite over hypotenuse. Now in quadrant number 3, only the cosines are positive, and I'm done. Let's go cosine of this. Cosine is going to be SOHCAHTOA, so opposite. Oh, I'm going to write this down because I am getting tired of, and I want to make sure not to make a mistake. So from this angle, I'm going to do adjacent. Adjacent is going to be 1. It helps create, that's the side that helps create the angle, and it's not the hypotenuse. So 1 over the hypotenuse 2. So 1/2, and we can see in quadrant 4, the cosines are positive. Tangent of this angle. Tangent is opposite over adjacent. So opposite is radical 3, and adjacent is 1. Tangents are not positive, only cosines. Now let's find the cosecant, secant, and cotangent of the specific angle. Okay, so when I flip this around, I know it needs to remain negative. I know this needs to remain positive, and this needs to remain, oh, this should have been negative. I'm getting tired of making small mistakes. Only cosines are positive. Okay, so this will be negative as well. Now, when I flip this or take the reciprocal of it, mathematically that's correct, but it's not in proper form. So I'm going to take square root of 3 and square root of 3. I'm going to show you the trick to it later on. Is there a quicker way? Actually, now is a great time. So here's the trick to it. So how can you quickly rationalize the denominator? You're going to take whatever's on bottom and you're going to throw it on top. So 2 radical 3. And then you're going to write the number that was previously on the bottom as is with no radical on top, or no radical over it. So if I gave you, in a quick example here, if I said 5 over radical 7, what's the quick way? I say 5 radical 7 because I take this, I throw it up top, and then just over 7. So that's the quick way. So if I take the reciprocal of this, again, it's looking like this, but that's not in correct form. So I throw the radical 3 on top, 2 radical 3, and then write the 3 in the bottom. Negative 2 radical 3 over 3. Let's do the next one. Well, I can flip this. I don't need to worry about rationalizing the denominator because there's no radicals. And over here, we're going to have the exact same problem. So if I write 1 over radical 3, mathematically it's correct, but I need to rationalize it. 1 radical 3 over 3. Do I need to write a 1 there? It's not necessary. It's assumed, but you're welcome to write that down if you prefer.